Due to the dry season, it's really getting hot nowadays, and I don't have an air conditioning unit. But what I can do is monitor the temperature and humidity of my environment using a temperature and humidity sensor, and I'll display it using the LCD display module. Let's go ahead and build it, shall we? In order to build our temperature, humidity, and heat index monitoring device, we need to know some terms that we will use in this video. Temperature refers to the degree of hotness or coldness measured in a definite scale. Humidity refers to the dampness of the environment. Heat index is the perceived temperature or what we really feel that is factored with the relative humidity. To compute the heat index, this is the formula. Oh, don't worry. We will not be doing any type of calculations because it is already implemented in the library. For this project, we will need the following: LCD module, Arduino board, a DHT11 sensor, breadboard, USB to B connector, and some wires. That's it. For the LCD, we will use the LCM1602 board, which is directly connected to the 16x2 LCD display. This board enables us to use the I2C communication protocol. Then for the sensor, we will use the DHT11 module, which is a basic low-cost temperature and humidity sensor with an accuracy of positive or negative 5% for relative humidity and positive or negative 2 degrees for temperature. Here are the specs of the sensor. For this schematic, we will provide power to the modules directly from the Arduino board. Then for the LCD, we will connect the SDA pin to A4 and SCL pin to A5. Why? Because pins A4 and A5 can also be used for I2C communication. Then for the sensor, we will connect the signal pin to the digital pin 2 of the board. Done. Simple as that. Now, we will first test the LCD device by downloading the LCD library. We will use the Liquid Crystal Display I2C library in order to determine the address of the LCD. Since not all modules are the same, just go to this site and copy the code for the I2C address scanner and run the program. The site address can be found in the description below. Once the address is found, we will now proceed to the testing of the LCD display. First, we will include the LCD library that we've downloaded earlier. Then create an instance containing the address, column, and rows of your LCD display. Then, in the setup function, we will initialize the library as well as print the text that we want to show using setCursor and print functions. Upload and check to see if it works. Now, since it is working perfectly, we will now test the sensor. First, we will download the DHT sensor library developed by Adafruit. Then we will set the pin and the type of the sensor in the code. In the setup function, we will initialize the sensor, and in the loop function, we will read humidity, temperature, and heat index of the sensor every 2 seconds. We will view the output through a serial monitor to check for errors. Luckily, no errors were found in the device. Yay for electronics! Once that's done, we will display the output using the LCD display. Oh dear, it seems that we need to use a different character for the degree sign. Also, there are still characters from the previous greeting that are still visible, as well as not all output is displayed. Let's fix it. Okay, we will use the clear function, but it doesn't show in the output. Maybe we need to set a delay first, then rearrange the display so that we can see all of its output.
Marvelous. Job well done. Our device is now complete. Now, I have measured the mini studio at 5:24 p.m. which shows this data. Then we did the same outside. We can see that the heat index is high, which is what we really feel right now. Be aware though that this is just a basic low-cost sensor, so the accuracy is not that great. For the future, we can add other modules like RTC and SD card module to store the data in the specific intervals. But there are other devices that already has this, like for example, the MKR Wi-Fi 1010. I hope you learned something from this video and gain inspiration to create your next big project. As always, if you love the video, please hit the like button, share, and subscribe. Never stop learning, stay safe, and I'll see you in the next video.